1982, 10 years before the internet became a thing, a Canadian company released the NABU network. With the NABU Personal Computer, the user would connect to the network over cable TV to download software and use. This is a very quirky and interesting machine, but unfortunately this NABU doesn't connect to the network. The original network is of course long since gone, but we can emulate the network on a PC, thanks to the NABU preservation projects. In a previous video I did an unboxing and a minor repair in the power supply, but then I got stuck, because at the time I only had my analog scope. To find out why it isn't connecting to the network, we need something more modern. Luckily since then I bought a new fancy DHO800, so we're all set to troubleshoot this NABU. This video is sponsored by PCB. More on this later. Thank you PCB for supporting this channel. Okay, I double-checked the wiring on my RS422 cable. As far as I can tell, it's correctly hooked up. I have also added a couple of wires here so we can probe and see what's going on here. So let's plug it into the T60. And here it showed up. USB serial port at COM4. All good so far. So let's launch the NABU Internet Adapter software. Go to settings, make sure we have COM4. I'll have to double check, but I think this is the correct baud rate. I'm glad I checked, because that actually wasn't correct. So it should be 111.861. Okay, let's save and start. Well, we're not getting any activity. So let's turn the power on. The NABU beeped twice, and then it gave me 3 beeps in a row. And we have an adapter failure. Let me try to restart the software with the NABU turned on. No difference. Let's try reset. No, there is no activity. So it still doesn't work. Okay, let's start by checking if this RS422 cable works at all. When I boot the PC, the yellow LED flashes and then the red LED turns on. I have the scope hooked up to TX+. So, in the terminal I'm going to set it to serial. As I mentioned, the RS422 is hooked up to COM4. So we'll change this to COM4. We might as well try that weird baud rate 111.861 and open the terminal. Now let's press some keys and see if we get any activity on the scope. Yes, there is something. I noticed that when I press a key, the green LED flashes. So this cable may actually be working. Okay, here's the reason why I didn't want to move on with this project with my analog scope. We do see some activity, but it's just flashing by. So let's do a single shot. And there it is. We've got 2.9 volts peak to peak. Okay, so this is how it works. Or it should work, I should say. This is our server sending a signal to the RS422 driver, and out comes the same signal on TX+. But we're also getting the same signal here, but reversed. The receiver in the NABU will output the same signal with perfect logic level. And if this signal here is getting distorted or is losing some amplitude, we'll still get perfect logic level, because the receiver only cares about the difference between these two signals. So this is pretty clever, at least if it works. So channel 1 is still hooked up to TX+. But now we also have channel 2 on TX-. Okay, so let's take a snap and press one of the keys on the keyboard. And boom, there it is. TX+ is the actual signal here. And as you can see, TX- here is the same signal reversed. If you're getting bored, you can always decode that signal and write down in the comments what letter this is on the keyboard. I think the first bit is a start bit and the last bit here is a stop bit. So you should probably ignore those 2 bits. Inside the NABU, the RS422 is hooked up to this DIN connector here. This chip here is a UA9637 receiver. And here we have a UA9638. That is our driver chip. Well, they are upside down, so perhaps the bits are falling out. Stolen jokes aside, here's the pin out for the receiver chip. I haven't read the datasheet yet, but it seems to take 2 pairs. Let's try with pin 7 and 8 here. 1 in plus and 1 in minus, and see if that's where our signal is. Okay, channel 3 here is now hooked up to 1 in plus, and channel 4 in green here is hooked up to 1 in minus. Let's turn channel 3 and 4 on, take a snap, and we're getting nothing. So now we move the probes to 2 in plus and 2 in minus. So let's take a new snap and send a signal. And there we have it. That looks like an exact copy of the original signal. Okay, so cable, connector and these passives here all seem okay. Since the signal is hooked up to the 2 ins, let's try the 2 out next at pin 3. Okay, that chip probably needs power, so let's turn the NABU on. Take a snap and send a signal, and it works. So that chip is okay, I think. Okay, so my guess was right. The first bit here is a start bit, because I think it's missing here. And the last bit here seems to be a stop bit, because it has been removed here. Well, unless... well, it's hard to tell actually, because when we're not sending a signal, it's actually set high. And the stop bit and start bit, they are high too. So they may actually still be in here, I can't quite tell. But we definitely have what looks like a working signal. It has also increased to 4.4 volts peak to peak. So it does exactly what I was expecting. We have a slightly increased signal coming out of the receiver. Almost perfect logic level. So that brings us to the TR1863 UART chip in the NABU. The last thing we can check here is if the signal is reaching our RX pin here. So let's probe pin 20. It's a 40 pin chip. So this should be our pin 20. Okay, let's turn the power on. Okay, so that signal is actually going high immediately. So let's take a snap. Okay, that is looking good. Except for the first and last bit that we can't tell if they are high or not. That signal looks like a perfect copy of what we're sending to the NABU. So that means the PC, the USB port, the RS422 cable and the NABU is actually working. So why doesn't it connect to the network? Okay, I did some thinking. What if the server is waiting for a signal from the NABU? Some sort of a handshake. So let's probe the driver in the NABU. Okay, channel 4 here is plus and channel 3 is minus. So let's change the trigger to channel 4. Take a snap and power on the NABU. Okay, we either have nothing or it's just not triggering. Okay, apparently I was just too quick. So let me do that again. I'll turn the machine off. And since that signal goes high, I'm gonna turn it on first. And then hit single. After the signal has gone high. Otherwise it's just gonna trigger and take the snap of the signal going high. And there you have it. So a few seconds after the boot, we've got this. So it is sending some signals to the server, and we also have the reverse signal here. So this tells me the NABU has a working RS422 connection to the PC. Okay, so let's do one final test with the server. All probes hooked up. Let's take a snap and start the server. Now we're getting absolutely nothing. Well, as you may know from the unboxing video, the NABU is a bit over-engineered. So, although it was kind of fun to play around with RS422, it's not really needed. The cable is very short, and as most people, I don't really have anything nearby that could cause any interference. So, let's convert this NABU to take regular USB instead. Because the only thing I can think of is that there is some kind of incompatibility issue between this RS422 cable and the server software. So the only thing we need to do is to bypass these two chips and connect directly to this chip here with an FTDI. To make this possible, I ordered some PCBs from the sponsor of this video, PCB Way. I found these PCBs on the shared projects page. I will put a link down below if you're interested in building one of these up. To convert the signal from USB to regular serial communication, I'm going to use this FTDI 232. These are, by the way, designed by mygeekyhobby.com. So let's unwrap those PCBs and have a closer look. So these are basically interposers that disconnects the RX and TX pin on that large chip. And instead of using RS422, we can do all the communication with an FTDI. I think we need to start with this row of pin headers, because we won't be able to access them once the socket is installed. I'm gonna use an old machine socket to get those pins soldered nice and straight and place the PCB on top. Before we solder, let's check with the socket installed. Well, that is a very tight fit, at least with the sockets I have. I wish I had moved the socket slightly in this direction here. That would have made my socket fit better. As it is now, these pins here, they are actually pushing against the socket. It does fit, but there might be a problem installing the socket after we have soldered all these pins. I think the easiest thing to do is to try and see how it goes. But first, I'll add some flux. I think my flux pen is drying up. I'm not using it enough. But I'm only using it on new PCBs. So those flux pens seems to last forever. On this row of pin headers, I'm going to be a bit stingy with the solder, since we don't have much space. Let's try with the socket. Now that two of the pins are soldered, it's pretty tight, but I think it fits. My guess is that he had machined sockets in mind when he designed these boards. They have a bit more room on the inside, so I'm actually going to solder these pins with the socket installed, with the exception of the two outermost pins. Here's a machine socket, by the way, so when installed there is a lot more clearance under the machine socket to the right here. I'm going to install the FTDI in female pin headers, in case I ever need one urgently and don't have time to order a new one. Okay, all the soldering is done. There are also pads here for an optional crystal. I think it just arrived in the mail, so I think we'll install it later. But it's not really needed, so let's do the first test without. The RX on the FTDI should go to the TX on the chip, and it does. This pin should also be disconnected from the socket, and it is. The TX should go to the RX, and it does. And the RX should be disconnected from the socket underneath, and it is. We are also going to need ground. That works too. So we're good for a proper test. By the way, there are some empty pads here. They are for a different module, so don't solder them to the FTDI. I didn't check all the pads, but one of the traces is actually sending the TX to the RX, so that wouldn't work too well. A quick and easy way to test an FTDI chip is to run a terminal, set it to serial, check what COM port it's connected to, in this case COM6, and change this to COM6. So if we type anything on the keyboard, we're getting nothing on the display, because the terminal is looking for a signal coming from the FTDI. So if we short RX and TX, the FTDI is going to receive whatever it's sending out. So if we type on the keyboard now, we're getting the same characters as we're sending to the FTDI. You can use that same trick to test other similar boards and irregular COM ports. By the way, this machine has some really funny looking caps. They look like tiny skyscrapers.
This looks like a city. I read that in a Danish book this morning.
Okay, so let's install our interposer. I noticed something odd here. This UART chip has some solder residue on the pins. I have seen this before on chips from eBay. What the heck is a desoldered chip doing inside a completely unused machine? I guess I'll route this cable through the back here later. Not sure what order this should be done in. But let's try to start the server first. And then the little city. Did not receive a hello message. Got 00 restarting. Okay, we didn't get that before. So something has changed. I guess we should restart the server. Disconnecting client, the port is closed. And start up the server again. Initializing COM6 at 111.865. Oh, that's incorrect. I think it should be 861. Let me check. Yes, I checked. That is incorrect. 111.861. And let's start the server again. NABU network adapter simulator server running. But nothing is happening. Let's try the reset on the NABU. Oh no, this isn't working. Crap, what's going on here? Something is wrong with this NABU. So although everything seems okay on the scope, it just doesn't work. Well, after a few minutes I got that same error. Didn't receive a hello message from the NABU. But we clearly saw on the scope that the NABU did send something back to the PC. I obviously don't know how those signals should look like, since I only have one machine and it's not working. So let's try a different software. So this is the Internet Adapter software version 2 for Windows from the nabunetwork.com. Okay, let's give this a try. Let's go for NABU Basic 2.0 and start the server. Listening for NABU. So let's power the NABU up. Unknown command. And a whole bunch of zeros. Okay, so what does this mean? And we've got the usual adapter failure. So let's stop this and try something else. NABU network cycle V1. Let's give this a try. Listening for NABU. I'll reset. Same result. Let's do a cold boot. I'll stop the server and start it again. And then turn the machine on. Now we're getting an unknown command. So it actually seems like there's something wrong with that signal that the NABU is sending to the server. Let's try the NABU network V2. I just realized we didn't set the baud rate. And it's already set to 111.865. So should it be 111.865 or 861? Let's try with 1. No, still getting an unknown command. And an adapter failure. Let's check if it behaves differently with the RS422 cable. So I'll change to COM4. And I have removed the interposer, of course. Okay, no error message this time. But it didn't connect either, and we still have an adapter failure on the screen. Okay, so not even an error with the RS422. Well, there has been an issue with flow control with these boards. I'm sure I read somewhere that has been fixed in software. But let's make sure this is an easy fix. Only thing we need to do is to connect the CTS pin here to VSS on this pin here. Easiest way to fix this is to add a bodge wire underneath the board, like so. I also found out crystal in my mail. And here's our 1.8 something crystal. So that crystal fits on these pads here. Oh, this is embarrassing. I'm going to be banned from YouTube after this video. I didn't examine these boards. So check this out. Pin 17 is disconnected and has to be manually connected with some solder here when this board isn't used with an external crystal. And with an external crystal we need to solder a blob on these two pads here. How incredibly embarrassing. Well, I'm leaving my mistakes in. So let's just quickly solder these two pads together and forget this ever happened as quickly as possible. Okay, so pin 17 on the chip is still disconnected from the socket. but it's now connected to the crystal here. I'll remove this bodge wire here. Okay, let's reinstall the interposer. Okay, let's change the baud rate to 115/200. Since we have that new crystal on board, we are at COM6. Let's save and start the server. NABU network adapter simulator server running. Let's start the NABU. Did not receive a hello message. Got 00 restarting. Still the same issue. Well, for some reason the NABU just hanged. So something is wrong. I double checked my soldering work. So I'll reseat everything with some deoxit. No, something is wrong here. The NABU doesn't post. It just completely hanged in post and doesn't even reset. Let's try with just the original chip installed. Turn the power on. Oh no, something else broke in this machine. Oh no, now it woke up. So why was it so slow to boot? That took much longer than it did before. Reboot a few times and see if it's consistent. Okay, it operates normally. So what the heck did just happen? Now it works normally, but for some reason it was extremely slow to boot, but only once. Okay, let's try with the interposer installed again. Yeah, now it acts normally. It posts just as it should. Well, sometimes deoxit needs some friction and a few minutes to do its magic, so maybe that's what happened. Okay, so let's try again and start the server. Serial init mode. Retronet TCP server incoming buffer cleared. Oh, it boots! I think it boots! Yes! So it was that bloody RS422 connection. But it looked normal on the scope. So what the heck? You saw it yourself. All those signals looked fine. And yet it didn't work. But hey, we're online. Like it's 1982. Nothing bloody works. Oh man, after all that probing and testing, this damn thing finally works. Where's that lovely keyboard? Okay, so how does this work? I have a lot of catching up to do with the NABU projects. Educational channel, nah. Family fun. World of games, that sounds like fun. Antarctic Venture. Well, let's give that a try. Now this thing even has ads from 1982. Antarctic Venture loading. Oh, we probably need a joystick. I forgot to check, but I think it works with regular joysticks, like for the Commodore 64. And it has 2 ports at the back of the keyboard. Okay, it boots right away. I don't need to restart the server. Yes, the joystick works. Perfect. So let's go to games again. By the way, how about that perfectly matching display? This JVC is about 10 years newer than the NABU, but it came in the same color and even the same font on the text. On top of the NABU, it looks like it's made for it. I have the brightness turned down on the display to make it look okay on camera. There is probably a lot more colors here. Yeah, sure enough. Well, CRTs never look good on camera. This is the best I can do. Well, it's pretty slow to boot the game, and it makes this very annoying sound. But then again, the Commodore 64 that came out just 1 year before this machine was incredibly slow too. Well, unless you had one of these. So maybe someone can make a turbo tape for the NABU. I have no idea how long this is going to take. I'll skip ahead here. Well, that game never loaded. But I tried several other games and they worked just fine. So that was probably just a glitch. I have to say, vintage computers are actually a lot more fun now than they were back in the day. Thanks to all the contributions to the NABU revival, there is a lot more you can do with it now than back in 1982. Also, these machines only had networks in Canada and I think briefly in Japan. Ideally, I would have liked to have a network card installed and run it directly to a proper online server, like it was intended, only this time over the internet, of course. I hope there is such a project, that would be really cool. After all, the NABU's claim to fame is that it was online 10 years ahead of its time. Well, whatever I'll do, There will be a link to that video on the screen shortly, if you're watching this in the future. If you're watching this fresh, hit the bell icon below and set it to all, to get a notification when the next video is out. And now is a good time to watch the unboxing and the first repair, if you haven't watched it yet. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you want to help me make more videos like this, like and leave a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, see you next week.